When we're working with the law of sines, you're working again with nothing more than a whole bunch of ratios. We're working with proportions and ratios of the sides and the angles opposite them in non-right triangles. Again, this is something you guys have all done. I don't normally worry about the reciprocal writing of this, but what it looks like is the following. The sine of some angle is to the side opposite. That's where they have the large, or excuse me, the capital letter versus the lowercase. Is to the sine of the other angle to its side opposite, which is the sine of the other angle to its side opposite. Again, you need to make sure that you guys are in degree mode in order for the law of sines, and then later on this week we talk about the law of cosines in order for that stuff to work. Law of sines you guys did last year. You did law of cosines last year as well. What's going to be a little bit different versus what you did in the past to this year is that we're going to talk about what's called the ambiguous case. There will be instances when the law of sines does not work. There will be instances when the law of sines could create more than one triangle. We're going to get into that a little bit more probably tomorrow because the other classes we didn't get that far, so we'll probably hold back after a few examples. So let's real quick just kind of jump into an example of what this stuff looks like. You notice here it's going to be a lot of fraction equal fraction, and when you have fraction equal fraction, what do? Cross multiply. So you're going to find out real quick this is really not all that scary. For example, again, it's not anything you need to worry about for right now. We're using law of sines when you don't have right triangles, and we'll get through the rest of the mumbo jumbo here within the next day or so. So here's what happens. It's going to ask you to solve the triangle. It's going to give you generic triangle ABC. It's going to give you an angle, a couple angles, and a side. It might give you two sides, one angle. There's going to be a lot of different parameters that happen now. Last year when you guys did this, everything you did always worked. This year, it might work, it might not work. There's going to be some variances, and we'll explain that here in a second. So what don't you see right off the bat? Yeah. How about a triangle? All right. Again, what I want to do here is just draw a quick generic triangle just to get the visual representation of what's opposite me and all that kind of stuff, just to get an idea. It is not to scale. Don't worry about any of that. Label out your parts. You've got 103, 28, and side B is 26. That means this is little c, this is little a. So in this instance here, excuse me, in this instance here, it would be considered what they call the angle-angle side. You've got two consecutive angles and a side that's not included. So on the side outside the angles. Can you figure out that third angle with relative ease? Yeah. What do you do? Yeah. Again, in order to figure out the missing angle, all you have to do is add up 28 and 103 and subtract it from 180, and you get? Yes, sir.
And just say natural labor, right? That part of natural labor where it's like big O, little, big X, big X,
I think I blocked that movie out of my mind. Anyway, so after you get to this point here, it's nothing more than using the law of sines to find the missing side lengths. One thing I want you to notice is that in the diagram, you're already given an angle and its side opposite at B. Everybody see that? Yeah. What I want you to do here, and I was talking about this yesterday, reuse your givens. When you reuse your givens, if you get it wrong the first time, and then you use an already wrong answer, you're always going to be wrong for your next answer. If you reuse your given and you got it wrong the first time, there is a possibility you'll get it right the next time. So try to remember that. So I'm going to say the sine of 28 is to 26, as the sine of 103 is to little c. Since this is fraction equal fraction, all we got to worry about is cross multiplying. So I get 26 sine of 103 is c times the sine of 28. Remember, the sine of 28 is just some crummy decimal. And I'm multiplying that times c. So how do I move the sine of 28? Divide. Just bring it back on the other side. And that's going to give you your missing side length. Now, what's nice is that you can type that directly into your calculator. Bless you. When you have the fraction one, just put it as a fraction. Alpha y equals 26 sine 103 over sine 28 and hit enter. Notice in your calculator it doesn't have slashy fraction bar. It has normal fraction bar. I'm getting, in this case here, it's telling me my side length is 5396. And now I do the same thing then to find the missing side A. Again, reuse that sine of 28 over 26. Okay. Cross multiply out. But is everybody okay with me shortcutting? Bless you. Shortcutting that first step. Yeah.
Well, we have to learn how to solve sine.
The missing angle? You can't do it without, unless it was special right triangles. That's the only one I'll ever require you to be able to do by hand. Sine of 30 is whatever. Stuff like that. Yes, sir.
What was C? What was C?
Oh, 54 and something?
53.96.
Yeah, 53.
Thank you.
Is everybody okay? Did everybody notice what I did here? I did my cross multiply and then I divided by that. I just wrote that as the next step instead of taking taking time to rewrite it out. Yes, right?
When we round decimals, do you want it to one decimal place or
2. I always round 2 decimal places. I always do 2. So in this one, what'd you guys get with 26 sine 49?
41.80.
And then lastly, obviously there's no real easy way to verify if your side lengths do match up. It's not like you can check it with the Pythagorean theorem. What I would do is just take a quick second and see if the largest angle has the longest side length, medium to medium, and smallest to smallest. That at least gives you a rough idea if you're somewhat close. Okay? What's that? So in this case, it works out nicely. But like I said, there's going to be instances when things don't work out. And this is when you have to watch your side angle. You have to watch your side angle stuff. I have it on the wall here. Now, what's happening with side angle, that means you'll be given something like that. 2 sides and then an angle. Okay? Now, what happens then is that you wind up with what they call the ambiguous case. And here's the way that it's worded. It's worded a little bit weird. What I want you guys to think about when they're talking about all of this is the following. When they're talking about A, B, and angle A, obviously that means that you could have angle C, side B, and so on. What this all means, and I have it all right here as well, is the given angle and the side opposite, and then another side. So again, the 2 sides, one of the sides has an angle opposite it, the other side does not. That's how they're pairing these things together into the 6 possible scenarios. Now, what we're going to do here is we're going to go through these, oops. We're going to talk about it in two different cases. The first one I'm going to talk about is if the given angle is obtuse. If you have a triangle and you have one obtuse angle, can anything else be bigger than that angle? No. Does everybody agree? Because you can only have one obtuse angle in a triangle. So remember the rule of largest angle is going to have the largest side. So what happens here is if your angle is obtuse, if it's obtuse, and the side opposite the given angle is smaller than the other side, no triangle can be formed. Because it cannot physically happen. Because the largest angle in a triangle has to have the longest side length across from it. That's what that means. That's what I know. Here, it's saying that if the side opposite the given angle is longer than the other side given to you, the triangle will work. Okay. It takes a little bit of time to get accustomed to the way that this looks and how we check these things through. Once you get the hang of trying it a few times and checking of what things are opposite you and what are not, it becomes relatively easy. Okay? You all right? What's up? Oh, that's my desk. Okay. So let me show you an example here real quick of the obtuse style first. Okay. You don't need to necessarily worry about what the triangles themselves are going to look like in these cases. What I want you just to understand is that if the angle is obtuse and the given side across from the angle is shorter than the other one, it's not going to happen. If it's bigger, it's going to be okay. So let me show you an example. Oops. Ooh, look at that. Forgot that I can be wrong. Smart boards are fun. So, in this case here, I have triangle ABC. I've got a given angle of C at 122 degrees. Side A is 12, side C is 18. I don't know if I mentioned this before. Am I going to yell at you if you don't put a degree symbol for angle measurements?
Yes.
No, because I forget it half the time. I forget 97% of the time anyway. All right, it's not a big deal. All right. You guys all thought the worst on that one, didn't you?
Yes.
All right. So again, in this case here, look at your given angle. The given angle is angle C. Everybody agree?
Yes.
What does angle C measure? Is that acute or obtuse?
Obtuse.
Okay, so this is obtuse. So that means I have to check and see if the side opposite angle C is either bigger or smaller than the other side given to me. Okay? Smaller or equal to, does that one work? So, angle C is side C is 18, side B, side, in this case it's side A, is 12. Oh, that works. So I know how many triangles am I going to get? One. Does that make sense? What I'm doing here is I'm verifying to see that this is going to work. This one I know is going to be, it wasn't going to. Yeah?
In that one, where you have C greater than A, is that a capital C or lowercase?
The capital C is the angle, the little c is the 1 by 18. It's very tough to write capital and lowercase c's because they're kind of the same.
Yeah, but that's huge. It's a way bigger than the A.
What do you do? Okay. So here's what we do. Does everybody agree that the side that we're given and the side opposite are the C's.
Yeah.
So let's use this to figure out what the angle A is. So I have the sine of 122 is to 18 as the sine of A is to 12. In this case, again, I'm going to have to cross multiply. But does everybody notice that I'm looking to find my angle?
Yeah.
Do you remember the button on the calculator you have to press for the angle?
Inverse sine.
The inverse sign, yeah. So what I'm gonna do is set it up just to leave the sign on one side. So I just have to multiply the other one by 12. So I get 12 sine of 122 is 18 is the sine of A. All right? Is everybody okay with that?
Yeah.
From this part, all you need to do is use your calculator. Let me show you how this is gonna look. I can type in 12 sine 122, hit enter, divided by 18, and that equals the sine of angle A. To figure out what angle A is, all I need to do now is hit second sine to get my inverse of my answer. You guys ever use the answer button?
Yeah. I did.
The answer button is the lower right spot, the negative, and that basically is storing the last bit of info you had in there, so you don't have to write down long digits or anything like that. You don't.
I wish you would.
You can just go up and then hit enter and it'll put it right in.
Second sign, second, and the answer is the negative button. And then hit enter.
I really wish I would have known that.
I'm surprised you guys didn't know that. What's that?
You can just go to your enter.
Yeah, I know, you can do that too. But I just always thought this was easier. So then you get
34.
34, 43.
43.
We okay with that? So that gets me 34. Now, I know that I've said many times, don't reuse your given, or try to reuse your givens. In this example, can I reuse my given to find anything out about B? No. I had to make sure I did this part correctly because now to solve for angle B, all I need to do is subtract out from 180 degrees. Everybody see that? What do you get for B then? 2357? And then how do I find side B? Law of sine.
I'm just saying you already know plus 12.
Very good. So, sine 122 is to 18 as the sine, what was it, 2357? Is to B. 18 sine 2357 over sine 122. Now they can be. And hopefully we got it correct. .49. They got the right answer.
That's funny. That was funny. I don't think that many people recognize that. I heard it, but it was. I thought it was
I got 8.4.
You rounded differently?
I just forgot that over digits.
Right.
Oh, that's. Is it March yet?
How's he smart weather? All right. All right. again, let's take a look at how this works. Now, this is going into the possibility of not having a triangle. So let me get into, make sure you guys got all that written up. If the given angle that you have from the law of sine stuff happens to be acute, which means it's less than 90, there's 4 different things that can occur. You can not have a triangle. You can have one triangle where it winds up being a right angle. And you can have a possibility of having 2 triangles. And we'll talk about how you create 2 triangles tomorrow. And you can have one triangle, just a regular old run-of-the-mill triangle. But in order to check that, you have to use those 4 possibilities. Again, the angle A is the given angle. The little a is the side opposite the given angle. So in the example I was just showing you guys, we have triangle ABC with little a at 4, little b at 2.5, and angle B at 58. So this example, my given angle is angle B. Is B acute or obtuse? Because it's lit.
Yeah, it's
Okay. So angle B is the acute angle. The side opposite it is 2.5. The other given side is 4. So what we do here is we just check. Take the other side, which is 4, times the sine of the given angle, and see, is it greater than 2.5? That's the first one we check. Because if it's greater than 2.5, we know we're not going to have a triangle. So,
No, yes it is. Yes.
I get 3.39. Is that bigger than 250? So that means that this, oops. That means there's no triangle. So we can't do anything. We just go to the next problem. All right. Again, what we're doing here is we're checking to verify if the triangle can possibly be made before we can solve it out. And what we're doing is we're checking to see if, in fact, you can get to that triangle. Okay? All right, cool.
Wait,
Wait.
I thought it said if A is greater than B, then there is a triangle. Oh, that's for obtuse. I went the wrong one. Sorry.
Apology
You
accepted.
gotta get your head in the game.
Okay. Again, we're going to try and solve this out. $70 is my given angle. Is 70 acute or obtuse? It's acute. So 70 is acute. So that means I have to check it. Is 160 sine of 70, check it against the 155.
small.
Okay. Do you mind it being larger or small?
Small.
It's, he's a step ahead of us.
I did it.
Yeah, it's
but I
small.
knew we didn't do it.
Okay. You get 150, 35. So it is smaller than the 155. So I know that I know I can throw out the no triangle. I know that there's going to be a triangle. So I check the next one. Did it equal 155?
No.
No. So I check the next one. Since it's smaller than the 155, is it also smaller than the 160? Yeah. It's also smaller than the 160, which is the third side. So that means how many possible triangles could we get out of here?
2.
We could get 2 possible triangles. Okay. We can get 2 possible triangles to make this work, which means we need to figure out where to start. Well, in order to start that, we use the law of sines just like you would normally. You're looking at me like I'm absolutely insane right now.
No, I'm just.
Okay, you just had that completely look of. All right, yes, sir.
So it says B and A. If like, I know like.
Don't
we
think.
use-
Just remember it as given angle and the side opposite given angle.
So which one's which?
Alright,
Is it?
so then, if we don't have A, but we have both the angle and the side for B, then we use big B and little b,
Correct.
and then whichever.
Yep.
Okay.
Yes, sir. I'll get you this.
There'd be one.
What happens here is when you're using trig, when you solve for the missing sign, when you're using sine, you're solving for it between 0 and 90. There's a possibility of that 0 to 90 being positive in another quadrant as well, so you have to work to the other quadrant. So that's what we're getting at. And we're going to talk more about the 2 triangle scenario tomorrow. Yeah. Hunter, you were, no offense, you was first.
In the given angle side opposite on the other side, the given angle is capital A, like for the formula.
Yeah, the given angle is always the
Capital A,
capital.
and then side opposite would be lowercase
Right.
a and then lowercase b. Okay.
I'm confused why 160 is B.
This is just, it happens, remember, the value of B, it could be A, it could be B, it could be C, it just means the other side. Okay. It's not always B.
Well, yeah, I know that, but isn't it right next to it?
No, it happens, it is. Remember, again, what we're talking about here, when they're looking at these A, B, and angle A, that could be any 3 of the scenarios here. It could be angle B with little b and little a. It could be angle C with little c and little a. It could be angle B with little b and little c. It could be any of those. All we're talking about is the angle and its side opposite in relationship to the other side. Bless you, bless you. I'm pretty seasoned. Okay? That's what it looks like. So again, when I set this up to do law of sines to start with, I'm going to try and solve out for angle C because I know the side opposite is. Okay? Sine 70, oops, is to 155 as the sine of C is to 160. What buttons do you have to remember to press when you're trying to find the angles? Inverse. Okay. We gotta do the inverse again here.
That's just for finding the angle.
Yeah. You only have to get the inverse when you're dealing with the angle measure. So that's giving me an angle of 7593, okay, for angle C. Is it 83 or 93? Now, I'm going to stop at that point because what happens after that, it gets kind of weird about how you work around to get to the secondary angle, because you haven't learned about the unit circle yet. But this part really isn't relying upon the unit circle, so we'll just kind of go over that tomorrow. Let me give you a couple of these to try for tonight, and then we'll build off of it then. If you come across a problem that winds up where you get 2 triangles when you're solving it, just solve for the first round of it, and then we'll use that as our example tomorrow to build into it.
How does your homework? That country? What's your homework?
Okay. The first 4 problems are just using the patterns to see whether or not it's 1, 2, or none as far as the triangles are concerned. The next few are I never showed you how to do that. Huh. Sorry.
Half our homework.
The next 4 are just using the law of sines. Draw a diagram and piece through it. There is a way to use the law of sines to help solve for the area of a triangle, but we didn't get to that. So the last couple are just using, it's very similar to a word problem, like the, what do you call it, elevation and depression was, but you're using law of sines instead. They're giving you the diagrams. You're just going to get kind of weird looking values. Wanted to see you guys how you substitute through it. Okay? We'll build off of this over the next day or so, and then we'll get into the law of cosines and all the fun that ensues from there.
Oh, Murph.
All right? Questions?
Ensue. He said ensue. Too soon though. That was